Good morning, this is your Stats Sensei, Mr. Spensei, and we're going to work on the test review. This will be only on scenario one. Scenario two will be in a different video. So the wholly independent school district claims that the mean time spent on homework by its high school students is 120 minutes per night. So that's the claim. So that's probably our population mean. We'll need to check that, but it's probably our population mean. So 120 minutes a night, almost 2 hours, with a standard deviation of 15. All right. A random sample of 60, so our sample size is 60 students, has a mean homework time of 115. All right, so this mean came from the sample, so this makes this our X bar. Test the hypothesis that the mean homework time is less than 120. So looking for a less than 120. There are 5,230 high school students in the Wally Independent School District. So this is a big high school. All right. So there we go. So we're going to start off by doing the hypothesis test. Oh, and they gave us an alpha of 0.05, the 5%. All right, so let's start going. What is our hypothesis? Well, our hypothesis is the initial claim, it's always mu equals. So in this case, HO, mu equals 120 minutes per night. HA, mu is less than 120 minutes. Please remember, this will always be equal, and this will always be 120, and we never include the sample mean. The parameter, let mu equal the true population mean homework time in minutes for Wally High School. All right, conditions, random sample. Well, they told us it was a random sample. And it was a random sample of 60. And that was given. Number two, N is less than 10%. Well, N equals 60. 60 times 10, it equals 600. And that's definitely less than the 5,230 high school students, because we're comparing it to the population, is less than 5,230. Number three, normality. They didn't tell us homework time, whether it was normal or skewed, but N equals 60. That's greater than 30 by normal by central limit theorem. So normal by CLT. Our formula, Z equals X bar minus mu, the standard deviation, divided by the square root of N. Drawing our picture. Well, the population mean is what we're centered on. We know it's less than. And how much did they spend per night? So they had 115 minutes. So this is 115. And that's our X bar. So mean 120. X bar 115. Sample standard deviation, our population standard deviation of 15, and N happened to be 60. And we are shading to the left. Ignore the D's, please. They shouldn't be there. Plug. So we want the probability that Z is less than 115 minus 120 over standard deviation of 15 divided by the square root of n. So this is the probability that Z is less than. Let's go ahead and run this thing. Stat test Z test. Mean of 120. 15 minutes. X bar 115. We had a sample size 60 and is less than. But we end up getting negative 2.5819. Probability Z is less than negative 2.5819. And that probability is 0.0049. So here's our p-value. Our alpha, they told us above, was 0.05 or 5%. And 0.049 is definitely less than 5%, so we're going to reject the null. So we need to write our conclusion. And our conclusion will be our p-value is 0.0049. Our decision, we reject the null. Why? There is plenty, sufficient, enough, sufficient evidence at, what was the alpha level? 0.05 to suggest that the true population mean homework time in minutes for Wally, that the true population mean homework time for Wally High School is less, and that came from here, is less than 120 minutes. All right, that'll take care of the hypothesis test. Now we're going to run a confidence interval for the same thing. Now, I'll be honest with you, I'm not going to restate all of the conditions because they're the same conditions. So the conditions will be the same, so I will not redo that. Hold on, I'm missing what I need. This should work. So for Wally, we have the same scenario, but it says calculate a 95% confidence interval for the mean homework time and comment on whether there's enough evidence that is different than 120 minutes. Okay, so our parameter. Well, our parameter is the same as what we just previously have. So let mu equal the true population mean homework time for Wally High School students. All right, I'm not going to redo the sample size. Redo the conditions, but the conditions were random sample of 60 was given. we had a sample size of 60. 60 times 10 is 600. That's less than 5,230. And we know that it's normal by central limit theorem because 60 is greater than 30. All right, but our formula we do need to include, which is X bar plus or minus Z star standard deviation divided by square root of n. And we'll go ahead and list everything that we need as well. So what we said we needed earlier was standard deviation, which was 15. So our standard deviation is 15. Our sample size was 60. Our X bar was 115. And they said they wanted a confidence level of 95%, so 0.95. So at that point, I need to calculate my Z star. My picture is going to look something like this, where this area right here is 0.95. We're centered on 0 because it's a Z, lower and upper. This will be an inverse norm. 0.95, 0, 1, and center. Second vars, inverse norm, 0.95, 0, 1, center. And we end up getting 1.9599. Plug. So when I plug in, X bar is 115 plus or minus 1.9599, 15 divided by the square root of 60. That test number 7, because we want a Z interval. And we run that, standard deviation of 15, X bar 115, 60, and a confidence level of 0.95 gives me an interval of 111.2 and 118.8. All right, we are 95% confident that the true population mean amount of homework time for Wally High School lies within the interval 11.2 to 118.8. All right, once again, this is our confidence level, so we just restated that. True population mean amount of homework time for Wally High School. That came from our parameter. And then we just restated our interval. So the meaning, this is talking about our confidence level. And our confidence level is in repeated sampling, we expect. In other words, if we did this over and over again, we believe this method will capture the true population mean homework time for Wally High School 95% of the time. All right, I believe there was one more question we still need to answer. It says, comment on whether there is enough evidence that it is different than 120. So they're saying based on our interval. And let's write that at the bottom. There is enough evidence to say that the homework time is different than 120. Why? Because 120 is not in our interval. All right, so there's enough evidence because it's not contained in the interval. If it hadn't been contained in the interval, then we couldn't say that. All right, thanks for watching. Hope to see you on the next one.